Welcome to today's Explainer. We're jumping right into the incredible journey of megaships. We're talking about everything from the fiercely debated wooden behemoths of the ancient world all the way to those luxurious floating cities of today. It's an absolutely fascinating story about breaking barriers and literally pushing the limits of physics. To start us off, I want you to just ask yourself a question. What is the absolute largest moving man-made object in history? Just ponder that for a second. We build skyscrapers that pierce the clouds, right? We have sprawling cities that cover entire landscapes. But when it comes to objects that actually move, we have to look past the land. We have to look to the sprawling oceans. And the answer? Well, it lies in a vessel that displaced an absolutely astounding 657,019 tons. Oh boy. That was the Seawise Giant. This supertanker was so massive that it completely reshaped our entire understanding of what human engineering could actually achieve. It redefined the absolute physical limits of what is possible to build and put into motion.
Section 1. The Quest for Scale.
So to really grasp why we even build these ocean-going monsters in the first place, we have to look at a fundamental historical challenge. You see, conquering the oceans was a hardcore economic and political necessity. Breaking geographical boundaries meant breaking physical ones. If humanity wanted to move more goods, trade across wider oceans, and project global power, well, they absolutely needed a bigger boat. And there's this fierce historical debate surrounding Admiral Zheng He's 15th century treasure fleet that perfectly highlights this. Back in 1405, during the Ming Dynasty, these massive fleets were launched as a huge projection of power. Official Ming records actually claim these wooden vessels were around 447 feet long, sporting up to 9 masts and displacing 20,000 tons. But modern engineering estimates? They push that length way down, more like 200 to 250 feet, displacing a much more modest 800 to 3,100 tons with just 3 to 4 main masts.
Section 2. The Wooden Ship Ceiling. Why do modern experts push those ancient measurements down so drastically? Simply put, a hard physical ceiling. Wood, by its very nature, flexes. While it's transversely strong, it is longitudinally incredibly weak. Experts argue that beyond about 300 feet, a wooden ship just becomes structurally unsafe. It literally lacks the rigidity to handle the immense stress of the open ocean. If a 450-foot wooden ship were to actually hit rough ocean waves, it would very likely snap right in half under its own weight and the force of the water. Nature basically imposed a hard physical limit on how big a wooden ship could ever get.
Section 3. Breaking the Iron Barrier. So, how did we finally get past that ceiling? We needed a complete material revolution. The Industrial Revolution essentially handed engineers the ultimate maritime cheat code, iron, and eventually steel. Tracing it back, we started with the wooden limits of Zheng He's fleet in 1405. But the introduction of iron changed absolutely everything, allowing ships to safely exceed 10,000 tons and completely shatter previous length barriers. By 1858, Isambard Kingdom Brunel launched his Iron Leviathan, the SS Great Eastern, and it was so revolutionary, its size record wasn't finally surpassed until 1901. Just look at this number, 692 feet. That was the staggering length of the SS Great Eastern. Brunel affectionately called her his Great Babe. Now, to give you some context on just how far ahead of its time this big boar really was, it completely shattered that 300-foot ceiling of wood and held the world size record for over 40 years. And this brilliantly illustrates the real-world application of such massive scale. As a standard passenger liner, the Great Eastern's operating costs were enormous, and honestly, it wasn't a huge moneymaker. But because of her unprecedented carrying capacity, she successfully laid the first lasting transatlantic telegraph cable in 1866. This iron giant quite literally wired the world together, making instant global communication possible for the very first time in human history.
Section 4. Monsters of Global Trade.
Fast forward to today, and we meet the modern steel giants that quietly and super efficiently run our entire global consumer economy. When we measure the staggering lengths of these vessels in meters, it's almost hard to comprehend. We've got the mighty USS Gerald R. Ford aircraft carrier at 333 meters, the highly advanced container ship HMM Algeciras at an incredible 400 meters, and then there's the legendary Seawise Giant oil tanker we talked about earlier at an unbelievable 458.5 meters. To put that into perspective, the Seawise Giant was actually longer than the Empire State Building is tall. Just let that scale sink in for a moment. But hey, it isn't just about length, right? It's about the sheer volume of what these ships carry. 24,000.
That is the mind-boggling TEU, or 20-foot equivalent unit container capacity, packed onto the HMM Algeciras.
So what does that massive number actually mean for you? Well, when you look at your phone, your clothes, the furniture in your room, it's this mind-boggling volume of global trade packed onto single megaships that literally makes our modern consumer ecosystem function. You and I rely completely on these hidden mountains of steel every single day.
And moving those mountains requires some staggering hidden engineering. The HMM Algeciras is powered by one of the world's most powerful marine engines. It weighs a massive 2,230 tons, is 22 meters long, and 18 meters high. Guys, that engine alone is literally the physical size of a standard 5-story building. And its entire existence is purely dedicated to pushing this logistical marvel across the world's oceans.
Section 5. Floating megacities. Now, cargo isn't the only thing we move on a massive scale. Over just the last decade, we've seen a stunning, rapid escalation in the size of modern Titan cruise ships. We have ships like the Norwegian Aqua at 28,000 tons, the MSC World America at nearly 216,000 tons, and completely dominating the field is Royal Caribbean's Icon of the Seas at over 250,800 gross tons. They are just getting bigger and bigger at an astonishing rate. And what does all that massive tonnage translate to? Well, you're looking at a vessel carrying the population of a small town, 7,600 maximum passengers and 2,350 crew members, fully self-contained right in the middle of the ocean. To keep nearly 10,000 people entertained, the amenities have to be totally unprecedented. We're talking 8 distinct onboard neighborhoods, the largest water park at sea with 6 water slides, over 40 different restaurants and bars, and an indoor park packed with over 20,000 real, living plants. Just imagine being the head gardener in the middle of the Atlantic. It's a level of overwhelming luxury explicitly designed to make you completely forget you're even on a ship. Section 6 is bigger, always better. As we look at these absolute behemoths, it really begs the question, can this exponential scale just go on forever? We are absolutely starting to bump up against serious environmental and logistical constraints. The shipping industry is being forced to adapt to ensure a sustainable future. So, instead of just building bigger, they're building smarter. Ships are actively transitioning to greener LNG fuel. We're seeing the integration of artificial intelligence for greater navigational and fuel efficiency, alongside massive advances in robotics and propulsion. Which leaves us with this final provocative thought. Will we ever see a 500-meter ship? Honestly, the engineering and new materials might actually allow it soon. But more importantly, given the environmental constraints and the sheer absolute logistical madness of trying to dock a vessel that size, should we? I'll let you ponder the ultimate limits of human engineering on that one. Thank you so much for joining me on this explainer today.